Alright guys, welcome to this page of the notes. And again, what we're doing is we're working on ellipses. And in this case, I have given you the equation for an ellipse. I ask you to find all this awesome stuff about it. We'll go ahead and graph it, but I can't use this equation. It tells me nothing. I've got to get it in vertex form so I can figure out H, K, A, and B and all that stuff. And the way we do that is by completing the square. So let's go ahead and complete the square. Again, I'm going to slide up a little bit. Again, if you're writing these notes on your own, you can probably squeeze it in, but I hate squeezing. I hate doing that to you guys. So let me rewrite the problem right down here, and we'll go from there. Again, the problem I gave you was x squared plus 4y squared minus 2x plus 24y plus 21 is equal to 0. And let's just jump right into it. We have done this a few times at this point. We've been completing the square for a while now in chapter 9. Here we go. I'm going to have x squared minus 2x. I'll put those guys together. I'll put the y's together. And that leaves me with a 21, which I will move to the other side. Now, I need the leading coefficients to be 1. That one's good. That one isn't. Pull that 4 out. If I pull out that 4, that's going to leave me with, what, a 6? Yeah, plus 6y. Now I'm ready to complete the square, so x squared minus 2x. All right, so I'm going to square 2, so a negative 2 squared is 4. 4 divided by 1. So I'm going to add a 1 to complete the square there, plus 4, y squared plus 6y plus. All right, well, let's see here. 6 squared is 36, and 36 divided by 9. So I'll need to add 9 in there to complete the square. And of course, algebra says whatever you add to one side, you have to add to the other side. But be careful if you pulled something out. Here, I didn't pull anything out. So since I added a 1, just add a 1. But this one, I added 9. So I'll need to add 9 to this side, but I did pull out a 4. So you'll need to remember to put that 4 back. So I'll add the 9 and multiply it by the 4 that I had pulled out. All right, these are now perfect square trinomials, easiest things to factor. We're going to wind up with an x minus 1 squared plus 4 times y. How about plus 3 will do it. All right, so then you have negative 21 plus 1 plus, what, 36? And I wind up with 16. And that's where we stopped for circles, but this isn't a circle, it's an ellipse. I need this whole thing to be equal to 1. So we'll divide everybody by 16. And we get x minus 1 squared over 16. The 4 cancels, reduces that 16 to a 4. So I'll have plus y plus 3 squared over 4 is equal to 1. Awesome. That one's good because this number is bigger than this number, which means that is my a. The a is always bigger. So that's my a squared. That's my b squared because the x comes first. This ellipse is going to be oriented horizontally. Here's what I now know. H goes with the x. You look at that right on the formula sheet. So it's x minus h. That means that h is 1. It's y minus k. So how did I get a plus 3 in there? Well, you get a plus 3 in there if k is a minus 3. A. That's a squared. Take the square root. You get 4. That's b squared. Take the square root. You get 2. So my ellipse is centered at 1, negative 3. It's 4 units to the vertices, 2 units to the co-vertices. Let's graph this guy. All right, like we said, my center was at 1, negative 4. 1, 2, 3, 4. 1, negative 4. I'm sorry. Hey, hold up. That doesn't sound right. Did I do that right? 1. Nope, sorry. Negative 3. My bad. I'm glad I checked. Glad I checked that. That was almost bad. Oh, shoot. Oh, darn it. I apologize. I moved. Scratch that, just go up 1 right there. There we go. Sorry, I'm going to have an extra dot in my graph. Ignore that point. Sorry, right there, 1, -3. Okay, now I know that my graph, right, remember the x came first, so it's oriented horizontally, and a was equal to 4. So I got to go 4 to the right, 4 to the left, because the major axis will have to be horizontal. So 1, 2, 3, 4, there's a vertice. 1, 2, 3, 4, there's a vertice. That's my major axis. Okay, B was equal to 2. And that'll have to go vertically, so up 2, 1, 2, minor axis, down 2, right there. There's my minor axis, representing my co-vertice and my co-vertice. You can certainly draw that ellipse in there if you wanted to. Okay. All right, I'll take that. That'll work. So, let's go ahead and get the stuff that I asked you for. I asked you for the center, which is going to be at 1, -3. I ask you for the vertices. There are 2 of them. I have a vertice at 1, 2, -3, -3. My other one is at 1, 2, 3, 4. No, hang on. 1, 2, 3, 4, 5. Learn how to count, Lawrence. 5, -3. My co-vertices are at 1, -1. And 1, 5. 1 -5. I am really struggling with counting today. 1, 2, 3, 4, 5. Awesome. Okay. Let's see. What else do I ask you for? Ooh, the major axis. Count it. Just count it. 1, 2, 3, 4. So to go the rest of the way would have to be 8 multiplied by 2. The minor axis. Just count it out. 1, 2 multiplied by 2, so the minor axis will have to be 4. Fantastic. And then finally, that last little bugger I ask you for is the foci. And that's going to require the use of the Pythagorean Theorem. Hey, let's see if I can copy it right this time. It is right there on your formula sheet. It is C is equal to A squared minus B squared. We'll take the square root of all that. Awesome, here we go. A was 4, so that'll be 16. B is 2, so that'll be 4. Oh, I wrote plus again. We wind up with what? The square root of 12? I think that's what we wind up. Square root of 12. All right, that is approximately, my calculator tells me the square root of 12 is, did I even do it? Here, I got a calculator right here. Let's take the square root of 12. Square root of 12. 3.46. 3.46. So what that means is that from the center, you'll go 3.46 units to find your vertices. 1, 2, 3. Wow, it is nestled in there like real close to that guy. 1, 2, 3.4. Oh yeah, look at that. Those are nestled right up in there pretty close to those guys, but that's going to be your foci. And that takes care of this problem. Guys, at this point, hopefully you're feeling real comfortable with completing the square. You're going to have to do it for everybody. We did it for parabolas, circles, now we did it for ellipses. We're going to do it in the next section with hyperbola. Also, hopefully you are getting more and more comfortable with using that formula sheet once you know the value of A, H, and K to go ahead and find all of the other stuff I could ask you for, or just dropping that thing onto a coordinate plane and going from there. Please, I give you a coordinate plane, please feel free to count stuff out. But you could just as easily use that formula sheet using your A's, your H's, your K's, the A's and B's and C's and all that stuff running around to get all of those as well. Thank you so much for joining me for this set of videos. I had a great time taking a look at ellipses with you. Can't wait to see you for hyperbola. Bye.